So this is something new in C++, and this is from C++ 17. So what is this string view? Basically, we know like what is this std, the traditional string, right? We already know what is this string str meaning. So this is your std string, traditional string, correct? If I initialize it with, let's say, Rupesh, and then maybe if I initialize this str into, let's say, same data type, str1 is equal to str. If I do this, it's just copying to another std string str1. The same size will be copied into this, meaning we have to create a new object and the same thing will be copied here. I do not want this, or in order to understand this a little better, there should be a way, because see, this is one string constructed on, let's say, some memory block, let's say 0 cross 1, okay, and this address is there, maybe 0 cross, I don't know, something, and we are just simply existing. So this is existing. Now what I want is, I want to do hell lot of operations on this stored string, but I don't want to copy or make so many objects out of it and do these operations. Like if I want to find, or to say like I want to get a substring, like say if I want to get like last 3 characters from here to here, I don't want this to get constructed again. If I say dot substring and get me the last 3 characters, no, I don't want that. I just want, there should be a way. If I say sub str 0 to 3, then it should be able to tell me like from 0 I will give you this one, this one, and this one. But I won't create an extra memory. I will just give you a view, and from that view you should be able to see only these 3 initial characters like rup, and that view, whatever I will return, that won't be a new memory constructed string. That view would somehow point to this originally constructed memory. So basically it's like, once you create some string and then later you can do so many operations on those strings without having to copy them, without having to waste so much of memory. So let's try to understand this with some example. So let's quickly see that. We have this piece of code here. This is a traditional string. We just create this string, and whenever we'll create this string, this overloaded new operator will be called, and then we will have this printed, like it is allocating how much memory and all that, okay? So if we are constructing this and then copying this into this, into this, into this, so like we are constructing 3 times, right? And then I'll just simply print it. So let's just simply compile it and just run this, and let me show you that. See, it is saying allocated 32, 32, 32, and then we'll just simply printing hello, this is CPP nuts 3 times. So you notice that I am printing it, I mean allocating memory 3 times. What I told you, right? Like there should be a way to just should be able to view that memory, not recreate it. So if we will use this string view, this is not going to copy that entire stuff. See, this time it is just allocated 32, meaning 1 time. It is not 3 times. It's just here. It is just simply copied here. And I can do this sub str like from 0 to, let's say, 5. Then we will get this hello from this str1 to str2 and then str2 to str3. But it will be just acting as a view. We will not construct any memory or anything like that. Let's just see that. I'll just compile this, and if I execute, see, it is still allocated 1 time, and then see, we have just hello and hello in this str2 and str3 because we are printing them here. But see, there is only one allocation. There are 3 different variables, and so it's like just a view. It's a window sort of thing which you get in order to access something which is created already somewhere else. So this is the main purpose. So now you see the power here. If you take any string in some function as a parameter like string view, because see, before the C++ 17, people used to do this by themselves, like saying that, okay, I won't change this string. I just kind of want a window so that I can do some sort of operations on these strings, but I'm not going to change this string. So what they used to do, they used to use constant string ref. Okay, but then also for that as well, you have to pay the burden to create a string. Okay, so now you see this beautifully, like, see, you are saying that str1.substr and this str2 is just pointing from here to here without actually constructing it. So how does it do that? Basically, string view needs two things: the starting pointer of the memory, like from where it has to start, and what is the size, meaning how much it have to point, meaning what is the window. So for this str2 and str3, window is this much only, hello is the window. That much only it can see. So I will repeat again, string view just need the starting pointer of that memory. So it will point this whole thing from the starting, and then it will tell you like what is the size. Okay, so size is 5, I told you, right? Size is 5. So it will just have window till this much. This is the only crux, and then it's up to you like how you are going to use it. There are so many ways you can use this. So whatever the functions available inside this string are also available in string view. All those things you can do in string view also. And this string view is a constant data type. It is not going to modify this anyway. Okay, it's just a view. It will have a window to actually see this, but it won't be able to modify. So this is available in C++ 17. This is really very beautiful. I love it because so many people need this. Generally what happens if you're dealing with some string, let's say there is this string here, generally this is observed that you don't want to change this string, but you want to do some operations on this string. Maybe you want this much part of this string sometime, and then you want to do something else, but you really don't want to change this particular string. This is like acting like a constant to you. So why would you go ahead and create an extra overhead or create extra memory for that? No, don't do that. And that's why C++ 17 gives you this feature. I think this is really very beautiful feature. Let me know in the comment section what do you feel about this feature, and I'll see you in the next videos. Hello friends, this is Rupesh and you are watching CPP Nuts video series on C++ 17 features series. And I know you are maybe confused like what is inline variable? We know inline functions are there and the uses of that, but what is this inline variable? Yeah, this is new in C++ 17. I'll be telling you 3 different important use cases. So just complete this video before leaving. So first use case is like, and yeah, first of all, why do we need inline variables? So here we can see inline int x is equal to maybe 10. So this is how you will write, correct? So if you write inline for any variable, it means it is going to be treated as single instance throughout all the compilation units. If you didn't understood this, don't worry, let me give you the examples. So if you have a.cpp and let's say b.cpp, e.cpp includes a.h. Okay, this includes a.h, and this further includes b.h, and b.cpp includes b.h. So we see that b.h is inside b.cpp also and a.cpp also. Now if this b.h is having integer x is equal to 10 as global variable just inside this .h as a global variable, and if you will try to compile this, it will give you the error saying that this integer x is having multiple definitions, because this CPP and this CPP are 2 different compilation units, and when you will merge them, try to make a single execution or binary file, then in that case it will tell that okay, I have same name but for 2 different places, and that's the confusion. So we all know multiple definition issue very well. So now this is the solution. As I told you that it will be treated as single throughout all the compilation units. If you put inline here just before int inline int x is equal to 10, and if this hierarchy is same, then it will compile. It won't give any error. So this is the first use case. Let's talk about the second one. Second use case is, let's say you have a class, okay, let's say maybe A, correct? And if you want to create a static variable int x is equal to 10. This won't compile because it is static. Hence it says you can just declare it, you cannot define it. Assigning 10 to x means you are going to define also. So this is not permitted yet. I mean, till C++17 it was not permitted. Now it is. So how would you do that? Just put inline here. Static inline int x is equal to 10. This would compile. And before that, if you have ever faced this issue, what you actually have to do, it was really very big pain, because then after defining this class, you have to put some lines here pointing out to this x, and then you initialize that with 10. Remember, you'll say something like a dot dot x equal to 10, and then you will write integer here just to give the definition of this x. So this was like clumsy. It was not that great. Now they have this solution in C++17. They have this static inline integer x is equal to 10, and this would do the exact job what this used to do without having to write these many extra stuff. So this is second point. Now let's move to the third point. Third is, I don't know if you have faced this problem, but if you ever wanted to create const expression with extern, this was not possible. Extern, we all know why we use that. Extern is used to just tell that I am going to declare something, not define. Meaning if you want to write extern integer x, here you says that I'm just declaring it, I'm not defining it. There is no memory allocated for this particular x. You're saying that right now I don't know where this will get defined. But if you put const expression, excuse me for the writing, at front of this, then this is not possible. I mean, this was not possible till C++17. Now it is possible. What you will do? You'll write const expression inline integer x, and then you can define also, like you can, cool, right? So we have these three very important points to use inline variables. Thanks for watching, guys. Bye bye, take care. I'll see you in the next videos. So guys, you know what just happened? I accidentally deleted this video. I'm going to reshoot this again. I don't know if I will be able to tell the same story again, but let's try it. So this is Rupesh. You're watching CPP Nuts video series on C++17, and this is any. So this can take any data type. So yeah, so this is about data type. So it can store anything with it. And whenever you want, you just tell that, okay, I want this data type, I want this data type. So it will give you that. Let's see with an example here. We have a configuration or setting class. Let's say we have a setting class. I'm going to keep this little small. So let's say in setting, you have the setting name. So we have a name here. This is going to be the string data type, right? And you have a font size, which is integer data type. And you have a font, let's say font name or something. This is again string data type. And for double, we can say, let's say we have a volume or something. Then we have a double data type. So can you see this? This is a class which is taking different data type, which contains different data types. And it would be very nice if you can just have a map here. Let's say we have a std map, right? So std map, you have to give two data types here. One is for key and another one is for value. So key, you will not be able to keep this any data type in this because it won't let you do that. But in value case, you can do this. So just imagine, let's say you have a string data type as key and value is any data type. So now just think of the possibilities you can have if you can do something like this. You have a key of string and then you can store any data type on that key as a value. So let's quickly see the program here. So this is your setting manager class. We have the object of that class here, and this is the unordered map which takes string as the key and any is the value. So don't just run away after seeing this class, okay? There are hidden gems I will tell in the end. So you have to stay till the end. Now I'm just setting theme color, font size and sound value. So you can see that values are of different types: string, integer and float or double. But if you see the setter here, we are just simply using one setter. So how is it possible? I am using a template here for value type because this is a different type. Then if I'm not doing this, I'll have to write different function just to take different data types, which will make the whole class so cumbersome. Now, once I have initialized it, I would try to get it. See, this is the get part here. And it is very important. I am telling the type here. Don't miss this part. I am telling the getter that, okay, this key is storing a value of this type. So see, this T is actually passed to get the typecast back. This is very important. I told you I have hidden jams here. So this is one of the jam, not the only jam, but very important. Any cast, I am telling, yeah, so this it is an iterator, and second is always the value, right? So value is stored here. So I did the find on name, whatever I'm receiving here. So this is like very obvious case. The important thing is this guy. The second is actually being typecasted back. Yeah, this is very important. And if you don't do this, it won't work because this is any. So in order to return something from a function, you will have to give the type of that, right? And in that case, this T, let's suppose for now is string, but this second is of type any. This is a different type. So it won't be able to convert it on the fly. You have to tell that, okay, I want to convert this into a given type. So this is a string type. Now rest is easy. You can query all these things, but wait a minute. What is this guy? Invalid string. This is to handle, let's say you don't have the given key. You are not able to go inside this. Then in that case, you will return a default value of that type. Meaning if it is integer, you will get 0. If it is string, it is empty string, stuff like that. So this is for that. So I'll quickly run this and don't go after seeing the output. I have not revealed the and jam or an important point. So this is your output. You can see that it is working fine. And let's say if I'm giving you, let's say integer here, sorry. And if I'll compile this and if I'll run this time it will give you 0. Yeah, see it is 0. So yeah, after watching this, yeah, so this is the second jam, what I'm going to talk now. What do you think what it is replacing? This is going to replace a void pointer. Yes, you remember you have the facility to typecast your data type, whatever it may be, to a void pointer. That is a generic pointer, you know very well. And then from void pointer, you can get it back. But the problem with the void pointer is, it is not a type safe. You can typecast anything to anything and your computer would actually do that. You just have to do void pointer conversion. And it's like, dude, I know what I'm doing, so just do that. But in this case, it is actually a type safe thingy. Let me do that. Let me tell that, okay, this I am going to take as string. Let's see how it is going to work in that case. If I'll compile it, if I'll run this, see, it is telling you that this bad any cast. So it knows that it actually contains something which is not integer. So it knows that, okay, yeah, there is something which is not right. But if it was a void pointer, it would have done it. And you would have seen some garbage stuff getting printed here. Cool, right? And yeah, in my previous video, what I mentioned that I did not post it. I mean, it got accidentally deleted. So in that video, I did not mention this point or what I have just included here because I teach on the fly. I don't make any notes or anything. So maybe this important point was missing. So I ran out of all the memories and I had to delete all the videos and I accidentally deleted my new recorded video, which is this video. So with this note, guys, if you learned something new today, don't forget to hit the like button, man. And if you like the way I teach and all that, you can consider subscribing this channel and share it with your friends, man. Thanks for watching. Bye bye. Take care. Hello guys, this is Rupesh and you are watching CPP Nuts video series on C++ 17. And I'm back with another video on C++ 17. So you must be wondering like, what is this clamp? So in programming, we have always this conditions, right? Like if your x is equal to maybe something, then you have like, if your x is less than 2, then return 2. Else if your x is greater than 5, then return 5. Else return x. So you can see that I am telling I have 2 and 5. If my x, whatever it may be, is less than 2, meaning it lies here somewhere, then return this guy. If my x is greater than this, meaning lies here and it is like infinite, I mean here also it is like infinite, then you just return this. Okay, if it is greater than 5, return 5. Otherwise return x, meaning if it is in between here, meaning if it is 3 or 4, return 3 or 4, whatever the x is. So instead of this 3 line, or I mean someone can come and then say that maybe you can use a ternary operator, but then that would also be like very clumsy. But here we have a very beautiful one line solution. So you can use std clamp. Here you give x, here you give 2 and then 5. And if your x is equal to 3, it will return 3. If your x is equal to 1, in that case it is less than 2, so in that case it will return 2. If your x is like 6, then this 6 is greater than 5, then in that case it will return 5. Okay, so this condition satisfies. So we are actually clamping these things together. You know that clamping tool which actually hold two things together so tightly, right? That's why we are also clamping this x with these two numbers. So we are just saying that whatever the x may be, I will have or I will accept values 2, 3, 4, 5. That's it. I mean, if it is integer. Small thing, but really very useful when it is needed, right? So thanks for watching, guys. Bye bye, take care. I'll see you in the next videos. Hello guys, this is Rupesh and you are watching CV Peanuts video series on C++17 series, and this video is about nested namespaces. So if you see this, it look like a pain, right? You have to create a class like petrol engine, and that should be in engine namespace, and that should go into a car namespace, and that should go into a vehicle namespace. Now, before C++17, it was always required to do things like this. I mean, you always have to write namespace, namespace, namespace. No matter how many namespaces are there, you just have to follow this. And this was a big pain. Now in C++17, it's gone. You can just simply write like namespace and then namespace name like vehicle and then car and then engine. And then you can create your class here inside this. Like class petrol engine. Cool, right? Now this is better or this is better? Obviously this is better, right? It is not really looking a very big thing, but if you just assume that maybe if you have 6-7 namespaces and then your class goes inside that, then just imagine like how the indentation would look like. I mean, your class will start from here and then you will start writing private and public and stuff like from here. So this much space is already gone, and if you try to do something here and suppose by mistake you hit indentation button and then you're gone. So it is really very good enhancement, and if you didn't know this, then this video really deserves a like button. Hit that like button, and if you want to see videos like this daily, then subscribe to this channel. I'll see you in the next videos. Bye bye, take care. So today's topic is std optional. This is new in C++17. I mean, it is being provided from C++17 and it's kind of an enhancement. You will love this because we all face this problem what they're actually trying to solve here. So let's talk about the problem. Let's suppose there is some function and you call this function with some parameter and this return type is maybe something. But depending on the logic, sometimes you return null pointer or null PTR or null or 0 because you want to tell that it is not present. What you was asking for is not present. So if you was asking for some object, if it is not present and you are asking in a form of pointer, then it will return null pointer, right? And let's suppose you are asking some value, if it is present or not. Let's say if it is integer, then you will have some sentinel value which you will pre-assume that if they are returning -1 in that case, I would assume that that value is not present. And let's say if it is string, then you might return an empty string and you will check, okay, the length of the string is 0. That means nothing is received. So you are actually assuming so many things just for one thing, that something is not present, something is absent. So you have denoted many sentinel values to tell that something is not present, then I will return this. But they have solved this problem. Now you have a class. Now let's talk about this. So this std optional is a template class, and as it is template, it can take like type here, you can say integer, and then this is your value. So this is how it would look like. So let's look at the code and we'll understand this a little better, because it's a better way to actually do the same thing what we've been doing since ages. So this is your code. I have tried to keep it very simple because as this is a template class, it has many functions. I mean, you go and explore that after watching this video, okay? Don't just run because you will not have the fun. Then, I mean, I also will not have the fun then. So this is what we do, right? I mean, this get some string is the normal function, what function we call, and this true meaning, it will return something meaningful. And if I'm not sending true, I'm trying to simulate it here. And in next case, we'll just send false from here and it will see like what it is doing.
So in true case where we are actually expecting some value, we'll initialize that value here, and this dereferencing operator has to be used to actually get the value from this optional class object, because it contains the value what you are returning from there, because it is an object which inside contains the value. So you have to dereference it, or just call dot value. There is a function to actually get it. So it's very simple. See, I'm not checking anything if it is null or something, because see, this is a string. I could have just done a return integer here, maybe some class object or anything. Now this is not a problem. You don't have to make all those assumptions or to check like if it is null pointer and all that. So it's very simple. See, I'm just assigning it here, and if it is present, this if condition will automatically detect that. And if it is present, it will print this, meaning CPP nuts. And if it is not present, it will say no value. Now you're confused. Do I always have to use this inside if condition so that it will check? No, there is a member function has value. If you check that, it will tell you that, okay, it has the value or not. So let's quickly run this. I'll compile this. It is compiling. And if I'll run this, CPP nuts. So it has the value. Now let's go for the false case. And now I'll compile and execute it. It says no value. See, I'm not checking anything that this string, whatever the string or whatever it is returning is empty or whatever it is. So you can keep this as it is and just change the data type and it will always work. And now let's talk about like the few theory parts, why it is important. First point is it is important because you don't have to worry about the type checking, because it is making your life easy to go for any type. This syntax is going to be the same. And second is code readability, because your fellow programmer will see your code and they will understand that, okay, there is a possibility that something will not come because we are using optional here. So they will be well aware by just looking at the code that the expectation is someday you will call this function and you won't return or you won't get anything. And third is to avoid the sentinel values. I already talked about the sentinel values. You choose -1, -5, -10, 0 or empty string or null pointer to denote that what I was asking is not present. You denote all that absence by all these pre-assumed sentinel values, but sometimes it creates problem. If your fellow programmer is debugging that, they won't know that, okay, if -1 is coming and you're checking -1, meaning what? I mean, was this not expected? Why you are checking explicitly the -1? I mean, you have to write many comments and all that, right? But now they have given the way to actually handle all these problems in a beautiful way. And don't think that whether it is going to increase the performance or not. This update was, I mean, this enhancement was not for the performance or something. This is for expressiveness, like how your code is written, how beautiful it can look if you are writing, or how expressive it is for someone else who is reading your code. To increase the readability of the code, this is a phenomenal job. So with this note, so you know what you have to do. If you like the video and learn something new, don't forget to hit the like button. And if you want to see more videos like this, consider subscribing and share it with your friends, man. I mean, they should also learn this. So thanks for watching, guys. I'll see you in the next videos. Bye bye. Take care.
Hello friends, this is Rupesh and you are watching CPP Nuts video series on C++, and this video is about copy and swap idiom. This is really very famous idiom in C++. So this is about writing a correct assignment operator function. So this is the traditional way of writing assignment operator function, right? Like you will pass by const ref, and then first you will check you're not assigning to yourself. If that is the case, then you just remove the previous data. I mean, delete the previous data and then allocate the memory and copy the previous data and stuff. Okay, so this is a very traditional way of doing it. But there are three problems here. First is, let's say, okay, I'll write here. If you are doing, okay, let's say you are doing A is equal to B. In that case, B is going to get assigned to A. Cool. But the point is, B can be very big, like maybe few GB data, and you don't have that much big RAM available. So in that case, you won't be able to initialize it properly. But to initialize that, you will have to come here. You will see this, okay, I'm not assigning to myself. It's correct. It will go inside, it will delete the destination data first, meaning whatever A was holding, that is deleted, and B is not copied yet to B, but A have already lost the data. I mean, whatever A was holding, that is gone. Now let's suppose you was at this stage and
allocation was not done properly, meaning you could not allocate that much big memory. Now you have the problem that you have already deleted your data, but you could not copy the B's data into A. So this is a very big problem, and we'll learn the solution of that problem only. Okay, so this itself is a problem. Like, if am I going to initialize to myself? I mean, 99% of the time you won't do that. Okay, but still this condition will execute all the time whenever you do the assignment operator call, and then this is the disaster in itself. So we know, yeah, there is a very big risk in executing this assignment operator. Okay, so this is always taught in the books and in colleges and everywhere. That, I mean, when I learned about assignment operator for the first time, I was also told this is the right way to implement it. And you always had to remember that, okay, I'm not assigning to myself. So these are the primary things. If you will ask someone to write in the interview that, okay, write a assignment operator, you will check all these things that, okay, I'm not self-assigning myself and stuff. So now I'm going to tell you that there is a better way to write the same thing. So this is the problem assignment operator. Now let's go to the solution of assignment operator. So now if you see, as this is a copy and swap allision, so that's why it is called copy and swap. So there are two steps involved in this. First, it is going to do the copy, and then it will do the swap. So that big function have now become a very small function. Now we are not receiving it as constant ref. Okay, so this is very important because you have to make a copy here itself. I told you, right? Okay, let me just copy this and paste it here so that it will be very easy for us to just refer that. I don't have to scroll again. Okay, so we had this problem that I was copying to the original, to the source location once I have already deleted the source location. Okay, like A is equal to B, A is deleted first, and then you will go and initialize A from B. Here it is not like that. Here your A is always safe. First you are making a copy of B because B is the right hand side data. B is coming here, and as this is copy by value, you will have to make a copy. So that copy is made here itself, okay, but not to A. That's why we need a swap operation so that you can just simply swap it, meaning just swap the pointers. It will not swap the entire array or anything like that, okay? Otherwise this will become a very costly process. That's why it is swap. And as this is a user defined function, which is mostly the case because then only you will go for assignment operator overloading, then in that case you just give your own swap function like this, and see, we have integer data, integer pointer data, which is an array, and the size is this one. So you just swap these two in the actual swap function of this buffer class, and you're done. So now see, now you don't have any problem here. See, you are totally safe. Let's suppose this would have failed. You didn't had that much RAM available. Then in that case, this will fail. It will say that, okay, I don't have, bad alloc. So bad alloc was coming here after deleting your data. First deleting the A's data, but here in this case, it will come here itself. Now your original A is always safe. You're not deleting your data. And once everything is available, like you can actually do the copy and stuff, then you just swap it. And it is fairly simple to understand this idiom. Now you know what is the better way of writing this function. So next time if you write the assignment operator in your interview, you should not write like this. You should write actually like this and give a swap function, and you should explain to your interviewer that this comes under copy and swap idiom. So I think we're done here. Thanks for watching, guys. I'll see you in the next videos. Bye bye. Take care.
So hello friend, this is Rupesh and you're watching CPNet's video series on C++ 17 series, and this video is about variant. So this variant thing actually replaces union, and it replaces for very good reasons. So let me show you a union case here. So I hope you remember like why we use union and all, right? Like you put bunch of data types like integer I, double D, character pointer C, and put them into union, and there is some struct here with some name. Okay, so this union is actually inside that struct.
Now, we all know like what is union. If you don't know what is the use of union, please go ahead and watch my video on union. And if you know that, if I'll do something like this, we have a name n and n dot I, let's say I'll do 10. And if I'll do n dot d is equal to maybe 10.1 and so on. Now we know that it will always point to the last modified value. That's why this is union. We are saying that I'll be needing any one of them at a time. I don't want all the values at the same time. So that's why it is union, either of these at one time. And the rule is whatever you initialize, what data type you initialize in the end is actually holding the correct data. Rest, if you try to access, that is undefined behavior. Yes, that is the pain, and variant will actually solve that. You got the point? Here you see that, okay, n dot d is equal to 10.1 is initialized. Now let's say if I want to print n dot I, this is not defined behavior. This is undefined behavior because this doesn't exist anymore. And there was no way to know that what variable do exist in union. And that is actually solved using variant. So let's quickly jump there. So if you'll see here, we have this variant. Instead of union, now it is a variant and this is a class. You give any type here, like we have integer, double and string here. So now consider this v as the union and we do v is equal to 42. We don't have to actually specialize that what value we are going to initialize to. So we'll just simply initialize this, this and this. And as it also works like a union, it will always hold this CPP nuts and it won't hold these. But now the question is, if I try to get the integer part, like the integer was 42. What if I want integer part? I should have a way to check if that exists or not. So this is the actual way. We'll try to get if this type from the variant. If this exists, in that case it will return the value, non-null pointer value. Otherwise it will return null pointer. So always remember this. If it has the value, in that case it will return the value itself. Otherwise it will return the null pointer. So the moment you return the null pointer here, you will know that, okay, I don't have to process this. Okay, you will go to the next one. You will go for double in this case. Does this exist? Okay, it won't go even here also because double also doesn't exist. Finally, it will go here. Let's quickly see that. I'll compile it. And if I'll run this, see, it is just printing CPP nuts. That's it. So it is actually a type safe. And before you had no option to actually verify that. You would have noticed that in C++ 17 and further, they are mainly focusing on improvising what we already have. Like the last video was about std any, which is introduced in C++ 17. There they were actually replacing the void pointer because void pointer have some issues and any actually solves that. And here also union is having some issue and variant is actually solving that. So many improvisations are actually happening, right? So I love all these things. Let me know if you like these improvisations. So bye bye, take care. Thanks for watching, guys. And yeah, don't forget to hit the like button and share it with your friends, man. Thanks for watching. Bye bye, take care.
Hello friends, this is Rupesh and you are watching CPP Nuts video series on C++ 17 features, and this is one of the feature. So we all know that if your x is like 2 multiplied by 2 multiplied by 3, and if your y is like 2 multiplied by 3 multiplied by 3, then if you ask for GCD, that is 2 multiplied by 3, which is 6. And if you look for LCM, that is 36. We all know that how to calculate all this, right? If you don't know, I'll tell you that greatest common divisor of x and y, I mean between x and y, how we'll calculate greatest common divisor. So if your x is like 12 here and your y is 18, right? So greatest common divisor is like the biggest number you can choose to divide both 12 and 18, and that is going to be 6 because we are looking for greatest. You can divide them with 2 also, but that is not the greatest one. So the greatest is 6, and after 6 you cannot divide these two numbers, so that's why it is 6. What is least common multiplier? Least common multiplier is like you're looking for a multiplier which is the least one. So if you go for the table for 12 and then 24 and then 36 and
18 and 36. So see, 36 and 36, they are common. But this video is not about like how to quickly calculate all these things. I was just giving you an idea. But this video is about we have this GCD and LCM available in C++ 17. So that's the best part. Let me show you that. So as I told, if we have integer x is equal to 2 multiplied by 3 multiplied by 3, and we have integer y is equal to 2 multiplied by 2 multiplied by 3, and I can just do std cout std gcd and x comma y, and if we'll compile this, it compiles successfully, and if we run this, the answer is 6. So the GCD is 6, and let's calculate LCM. That is going to be 36. I'll compile this and run this. 36. See, so you need this numeric header, and you have this LCM and GCD under std namespace. So if you are someone who uses GCD LCM quite a lot, now you don't have to define your own function. It's already there in C++ 17. So thanks for watching, guys. Bye bye. Take care.
Hello guys, this is Rupesh and you are watching CPP Nuts video series on C++ 17 features, and this video is about if constant expression. So there is a new kind of if available in C++ now. It is like if const expression, and then you will give this and this. So this is like very known to us, but what is this const expr doing here? So we all know that how if work, like it just compare the values, and if it is true then it will allow it to go inside, and if it is not true then it won't allow to go inside, right? So see, if this is my requirement, and now I'm trying to explain you like why do you need if constant expression. So let's suppose this is your template function, and this function does a very simple job. If this type t, whatever we are passing into this function here, if this type is integer type, here we can check that, like if it is integral type, then I'll just return that particular value itself. Otherwise, if it is, let's say, string, then that string dot length should get returned. I think I'm clear. If it is integer type, then this return should return the value. So whatever the value you just pass here, let's say we are creating this integer n here, and we are passing length n. So due to this function call, this t will be replaced with integer, right? We know that because this n is of integer type, and because of this string s call here, this whole function will be duplicated again, but then this t would be treated as string, correct? So there will be two copies of this length. One will be with integer types and one will be with string types. But this is not going to work. Actually, when it will try to do things like this, let's say if it will try to replace this t with integer, it will see that now this value is of integer type. What is this doing here? Value dot length. There is no member function for integer type, correct? So it will fail. It won't compile here. I think you got my point. Let me erase this and I'll show you that it is not working. So if I compile this and we see the results here, it says we have 2 errors generated. Okay. And if we see, like, it says that this constant integer is not a structure or a union, so this dot length will not work for integer. So it means it is not working, right? Like this is pretty clear demand that one time this length should return this and another time it should return this. But this is the biggest problem, and trust me, one of the time I also wanted something like this and I was stuck. I don't remember what I did after that, but now we have the solution here. We can just simply use const expression. If we use this const expression, then the biggest magic what will happen is this will be now dealing with at the compile time itself. Before, this if was considered to be executing at runtime, but now this is going to be at compile time. So Now, if I will just compile, let me show you that. If I will compile, see it compiled successfully, though there is no error now. Okay, let me recompile it, see it compile again. So basically what is happening, let's understand that. When this length is asking for integer, now it is with n, so n is of type integer, it will create length with integer and it will just put this there. What I mean is it will be simply like auto length, and then there it will be like this value, and this is your integer const ref value, right? Yeah, so this is what it is going to be in integer case, and in string case this integer is going to be like a string, but here value dot length will come because we have this if and else. If it is not integral, and in our string case it is not, I mean string is not an integral type, so this will be there. So only you will see this in case of a string function. So now there is no confusion, right? That's why it is compiling, and it is really very fast also. Why? Because in case, let's suppose this was working, just suppose that it was working, but then in every time you call this length, you have to check whether it is integer type, then you just deal with this, otherwise execute this. I mean, if it is integer, execute this, else execute this. So there is this if and else again and again. So there are some condition check, but now here it's very straightforward. So it is clean and fast both. So if you didn't know this, then this video deserves a like button, and don't forget to hit the subscribe button so that you can get the notification for upcoming videos like this. I will see you in the next videos, guys. Bye bye, take care. So guys, I'm back with another C++ 17 feature, and this is initialiser can reside in if else or switch case conditions. So what I mean is, if you have some variable and you want to check if that variable is greater than something, then only you want to do that. Meaning, let's suppose you have integer x is equal to, let's say we have this min function and I call this 5 with some 5 and maybe 10, and I just write here if and tell x is equal to 5, then only you do this job. Okay, this is my job. So this is pretty handy, right? I mean, this is what we've been doing since ages. But now in C++ 17, they saw that this is a problem, because let's suppose this is very big file or function, then in that x you cannot use again. And if you have so many conditions like this, you have to do like x1, x2 and all that, and that may kill the readability, or it would look little ugly. But now, do we have any better solution? Yes, we have. What is that? Let's see that. So I can write this piece of code like this. If integer x equal to min 5, 10, and then notice this here, I'm giving this semicolon and then say if x is equal to 5, then you do my job. This is your job. So this is now converted into this, and the scope of this x variable is inside if, and you can just write again same if for x, I mean integer x, and you can use this x again. So you don't have to put x1, x2, or if this x is some meaningful name to you, then you can keep that meaningful name throughout this function or throughout the function scope without changing it. So notice this syntax. Syntax is like this. This is initializer position, and then we have this semicolon here, and this condition check. So this is the new syntax of if, you can say, and this is applicable to switch case also. Let me give you a quick demo on this. So let's see this. We have this similar looking function, integer x is equal to min 5 and 10. Out of this, which one is minimum? And if x is equal to 5, in this case it will be true because we will have 5 as minimum. And don't think that this is really very trivial or silly example. Always this 5 out of 10, 5 is the minimum. What my point is, this is variable. Okay, you don't know this, obviously. Okay, so this might return anything, and depending on what it is returning, you want to equate whatever the return value is, then take the action. So this is about that. Just don't think that it's some silly stuff. It's really very beneficial. So let me compile this. Yeah, it compiled successfully. And then if I run this, see it is printing job. So meaning this syntax is really very valid syntax, and I can still use, or if I want to print this x here, then you will see a compilation error. See, we have error. It is saying that this x is not declared or defined. Okay, so this X is looking for this one, but this is actually local to this if only. So that's the best part. C++ is doing really very crazy stuff, right? I know. So if you didn't know this and like this point, don't forget to hit the like button, guys. Thanks for watching. I'll see you in the next videos. And yeah, don't forget to subscribe if you want to see videos like this. Take care.
Plus standard library. So today we'll try to understand the use of that. So before going there, I'll summarize in a single line like why it is used, and then I'll give you the example. So the real deal of using destroy function is to just deallocate your object, but without freeing the memory, meaning you will just call the destructor, but you will not free the memory where that object was stored. So if you have this kind of scenario, then it's better to use this destroy function to deallocate, or let's say destroy or destruct the object. So this is space construction only. So let's say you want to hold some foo class. Let's say you have foo class and you want to store like 100 elements of that class. Then you create a memory to store that much of foo, and then in that memory you just say that, okay, because you get a raw memory here, you will typecast it, and then you will have the buffer of 100 elements. So this is just the space construction, but there is no object yet. Okay, now let's go to the object construction. So this is the object construction. You will, let's say out of that 100 you are trying to create 20 objects, and this is placement new way of constructing the object. You will give the address where it should get constructed, and this is the object which is going to get constructed. So this is the place and this is the object. So this object is constructed here using placement new. I have already explained what is placement new and new operator in my previous video, like yesterday's video. So if you are interested, you can get that maybe somewhere here in I button. So this is now construction. So construction have happened. So initially you created the space, like just the memory. Now you have constructed the object on top of that memory. Let's go further. Now you destroy only the object but keep the memory. So this is what we want to learn. So this is the destroy function, and you will give the buffer, I mean the start and the end. So this is a range function. So like you will take start and end from where to where you want to call the destructor. So this is the starting point, and let's say 20 times, you created 20 objects, so you will give 20 here. It will call the destructor that many times for all the objects. And then this is the best part, reusability. Now you have again full length, like from 0 to 99, you have complete 100 elements buffer available to reuse it. Like you don't have to ask OS to get the memory again and again so that you can create a dynamic object on that. No, you don't have to ask, because that also takes some time, right? Because OS will have to give you some chunk of memory, so it has to do something. And if this operation is so frequent that you will create and destroy the object so frequently, then better use your own memory, like how we did in the first place. So you created this memory, and on top of that you always create and destroy the object. Okay, so yeah, we were here. Now we have done the reusing part. Now let's look at the final thing. You just destroy, like here you again created 5 elements, right, from 0 to 5. Then you create 5, and now you just destroy all of them. Now you have to do operator delete, because you have to remove the original memory. So now we are closing up. Okay, so your program is being terminated. Then you go ahead and clean that memory which you created first. So this one, let's look at the complete program in one shot. So we have the comments also. You can pause the video and try to just go through each and every line. It will make sense. Okay, now let's look at the summary here. So the summary is use of std destroy functions are, let's say if you're working with a row or uninitialized memory, then in that case you can use destroy function. Otherwise, if you are using new, let's say new operator, in that case you don't have to call the destructor, meaning you don't have to call the destroy, because anyway you're going to call the delete on that object. Then it will call the destroy, and it will call the destructor and deallocate the memory. So it will do two things. So if that is not the case, then you will use this destroy to actually destroy the object. Second case is if you have to create object using placement new. So we just saw that. And another is you want fine-grained destruction in a custom data structure, meaning you want to control the destruction the way you want, okay, in that case, or wherever you want. So in that case also you can use this on your custom data structure, and it's a low-level tool but essential for writing in safe, robust container-like classes. So meaning, let's say you have a vector, std vector we have, right? So let's say you're writing your own vector. In that case, do you think vector should always grow and shrink? I think not, because let's suppose you are just pushing the data into the vector, then in that case it will grow like from 2 to 4, 4 to 8, 8 to 16, and then let's say you're trying to destroy some element. Let's say you destroyed 8 elements. It will not go and flush out the memory, right? It will just keep that memory. It will just destroy the object. So it should destroy the object. It should not flush the memory, because you may push the data again, okay? Or like these all things are like requirement dependent. So if you want more control with you, then you can go with this destroy, and it looks cleaner, okay? So yeah, and yeah, let me just quickly go up. Operator delete and operator new. I have created video on these. You'll get the link in the description or maybe somewhere here. So if you're new to this, you can consider watching those videos. So I think we are done. Thanks for watching, guys. I'll see you in the next videos. Bye bye, take care. So hello friends, this is Rupesh and you're watching CPP Nuts video series on C++17, and this is about std visit. So we have this function available in C++17 and it is quite useful. It is tightly coupled with variant. So if you are heavily using variant in your program, then you might want to use this visit because it will help you ease out your calling. So variant, we have variant, and this can handle many types, right, at one time, because this is just consider union if you have not watched my previous video. So this is a union. It can have integer or string or let's say character or maybe float, and list is like unlimited, okay? So we have user defined and all that. So the idea is variant object, whatever object you will create, can hold all these data types, but at a time it will hold only one. So let's say if it is holding string data type, in that case you want to call some function. Maybe let's say you just want to call a print function. Whatever the object it is holding, it should get printed on the console. So that is the simplest job. But the point is, you always have to check what is the currently type this variant is holding, because depending on type, you will try to call that particular overloaded function. What I mean is, let's say you have a print function, and this print will take all these data types, right? So you will have to have, let's say 10 data types are there, you will have to overload 10 different functions. So first is taking integer and then so on like that. But the problem is, to call them you have to first know the type, what this variant data type is actually holding right now. So this visit is actually here to solve that problem, that if and else will go away. You just call this callable function without even thinking about the type. So this is the goal here. Just be with me. It is going to be fun. So let me just directly take you to the program here. We have these three functions, and we have vector of variant. So this is going to take either integer, double, or a string. So I am creating a vector. First it will hold 1 and then double value, and then it is going to hold string. So I'm taking these 3 different data types and we'll just loop over it. So first element is going to have this integer, right? Now see, we are visiting, we are not writing if and else here. That's what we are trying to get rid of, okay? So we will send this callable function to the visit that, okay, call this function with this parameter, and this element is nothing but the variant. You know that, right? Like how it works. Now this func is getting called here. So see, we have these 3 overloaded functions and we don't have to check the type. We are just calling these functions with the provided argument and it's just working. And without this, you have to check what is the type of this element, what it is actually currently holding, and then only you will call the appropriate function. So that's like a bigger pain. Now this is so easy. And now you might be wondering, like, why I am passing this auto ref here. So This is for actual type deduction. Whatever the type of this element is going to be, it is going to deduce the same type and pass it by reference. So that's for that, so that we can actually call the correct overloaded function. And now let's talk about how it is actually doing it. So basically it is checking the type of this element at runtime. Yeah, it is doing that for you. You don't have to do it. This is done for you automatically. So to summarize this, we have visit function. This takes at least 2 parameters. One is callable function. So this can be a lambda function. I have given the example of lambda function. You can go for like any callable object. There are many. And it takes list of variants. You cannot give any specific data type here. String, integer and character and all that stuff will not work here. It has to be variant, then only it will work. And this visit actually calls this callable function with these parameters, whatever the parameters you give for you, and with the correct combinations. Because I have shown you a just single parameter, it can take like n number of parameters with n number of combinations. Just the point is you should have that overloaded function, whatever the parameters you are passing here. Okay, so that combination should be existing. And it solves the problem that you don't have to write many if and else statement. It will do it for you. I mean, it will do the job exactly what you would have done by using that if and else, if and else, if and else, depending on the type. So with this, I'll see you in the next videos, guys. And don't forget to share this with your friends. It will help them and me both.